Okay, so here we are with part 2 for this lesson, and we're going to talk about the fact that different types of motion will give us different graphs. So I got 4 different examples of different types of motion that are going to give us different graphs, and we're going to go through them one by one. So the first is a displacement time graph that kind of looks like this, right? Where we've got displacement up here and time down here. And we notice right away the graph, okay, this is a horizontal straight line, right? So what this means is the position as time ticks away, tick, 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 the position of this object is not changing. So this object is staying still, okay? So it's not moving. We can also look at this by saying, hey, wait a second, the slope of this line is 0, which means that the object has a velocity of 0, and we can say it's at rest, okay? So we also notice it's above the axis, so it's got a positive position, right? So it's east, it's east relative to a reference frame. And so we could kind of draw a little example of this. We kind of say, all right, well, here's our coordinate, here's east, right? This is the positive direction, and here's 0. And so here's a dude who's sitting here, and he's just kind of standing still, okay? And he's at some position, right? And this position would be the same as this position right here. And so he's not moving. He's just sitting. And so time ticks on, tick, 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 and he's just sitting there. Okay? So conversely now, let's look at something else. Let's look at this one. This would be, let's try and stick with what we've got here. This right here, let's say we're going to set this up. We got a line that's down here. Okay? So obviously, this line as well, this is a horizontal straight line. Right? So once again, the slope of this is 0. So the object has velocity of 0, and the object is at rest. So we know this, right? This is just like before, but what's the difference now in a graph that was once above, okay, and now it's below? So now we're in the negative. So this person is at a constant position, but they're at a constant negative position. And what does that mean? Well, if they're at a negative position in our coordinate system, that means west relative to a reference frame. So here, what we actually have is this. Well, here's 0, here's west, which we know is negative, and here's the dude sitting here, but he's to the west. So again, same kind of thing, not moving, but because this is a position time graph, his position right here corresponds to where he is right here. Okay? So now what we're going to do is we're going to do something a little bit 0. So what I've done is I've given you the whole description, and we're going to fill in this, and we're going to fill in this as we go. All right? So this is what we have. So the graph is a straight line with a positive slope. All right? So right away we see, all right, straight line with a positive slope. There it is. Okay? Straight line, yep, straight. Positive slope, yep, that's a positive slope. And so what we need to recall is, wait a second, if this has a non-zero slope, then this represents some non-zero velocity, right? Whatever slope this line has right here is going to be the velocity of the object. Okay, good, so it's moving. This is a little bit different. This is different stuff. Now, because it's a positive slope, it means that it's moving in a positive direction, which means it's moving eastward. This is not a little fact. This is kind of like, it's one of those things that takes a lot to connect this. This has a positive slope. A positive slope means it's moving in the east direction. So if we were going to draw this, here's our coordinate system. Here's 0, okay? And here's our dude. and moving in, of course, an east direction, because this is east, it's positive, and this is where he's moving. You'll notice that whatever position he has here at this time, at time t equals 0, corresponds to this position, and however fast he's moving, that corresponds to his velocity here and the slope here. Okay? So last but not least is the same kind of thing, but of course you guessed it, we're gonna do something negative now. All right. So what we have is a graph that is a straight line with a negative slope. Okay, so instead of a positive slope, we get a negative slope. What that means is that this has a negative velocity. Negative slope means negative velocity. And with our convention, that means the object is moving west or westward. Okay. You'll also notice that if we do this, let's do this. Let's actually draw this line now. All right. No reason it has to stop at 0. We notice a couple other things. We've started kind of talking about this a little bit. Is that this right here means, hey, wait a second, this does not start at the origin. We're actually starting in the positive direction, and we're moving westwards, but we started positive. Okay? So what that means is that this guy right here, this would be 0. Okay? This is west, which is negative. This is east, which is positive. And you'll notice that at the initial time t equals 0, all right, so at the very, very beginning, you'll notice, hey, wait a second, at t equals 0, he's actually got a positive value for position. All right, this is a position time graph. So at time t equals 0, this position is positive. All right, so even though he's moving in the negative direction, he's getting more and more west, right, because he's running west, he's still initially started at t equals 0. And so what we say is that just notice this object does not begin at the origin. And that's a crucial factor. This one didn't begin at the origin either, but we didn't make note of it up there. We made note of it down here. All right, there is your 2 mini lessons on speed and velocity.